This is problem 124 of Neetcode 150 jump game 2. So we're going to be given an array of integers where each position is basically a step, and the number at this step represents how many steps further we can take. So this is very similar to the first problem, but this time, instead of saying if we can actually reach the last index starting from the index 0, we are going to have to give them what is the shortest path that could allow us to reach this last index. So for example, from the index 0, we can reach the index 1, right? Because at the index 0, we are allowed to take 2 steps maximum. So we can take 1 step. So you can go to the 4 or to the 1. But if you go to the 4, well, you're going to be able to go right away to the last index, right? So see that there are multiple ways to reach the last index. But if you go from 2 to 4, you're going to reach the last index directly. But if you go to the 1, you will have to make one jump to the 1, and then another jump to the second one, another jump here, which is 4, which is actually more steps than if you just go to the 4 directly and then jumps directly to the last index. So to do this, we're going to use a greedy approach, and let me show you how we are going to do that. So let's say that this is basically our array of numbers and our steps. So let's say that I am a pink dot here. Well, we know that the only way to actually enter the array is to go to the index 0. So you cannot start from another index than index 0. So let's create ourselves a roof. So a roof is basically, let's say that we reverse all this and it looks like a building. So let's say the 2 is the first floor, the 1 is the second floor, the 3 is the third floor, the 1 is the fourth floor, the 5 is the fifth floor. Okay, right now the only place we can go is to the first floor. Great. So now let's say we are at the first floor. From the first floor, we want to see basically how far we can go. So from this first floor, we know that we can go to the second floor or to the third floor. So we will create ourselves what I call a span. So I can basically, I have a span of possibilities that allow me to go to the third floor, right? And basically, I know that when I am at this particular position, I am reaching basically the floor, the roof of basically the roof of what I was allowed to reach, and the basically the floor of the next span of possibilities. So at this position, I will actually have to take a step. So this is going to be 1. So I will have to take 1 jump here, and I will have to jump to either 1 or to either 3, which is not necessarily clear now which one will be the optimal way, but we'll figure this out soon enough. So um, so yeah, when we are at this position, let's say that well, we're gonna be starting at 1, and we are gonna have a new roof. So now the maximum we can go through is this 3. So we are free to start from the 1, and we are free to start from the 3. So our roof is gonna be sealed at 3. So we're gonna go see like how far I can go from each of these points that I'm allowed to start at. So at 1, I can basically go to 3, which is not optimal. Okay, but we don't necessarily know that. We're just gonna set a temporary span of that is gonna seal basically 3. But then when I go see 3, I can realize that I'm gonna go to 1, to 4, and to the other one. So this is basically the other span of possibilities that I have when I start from there. So I will have a new span of possibilities at up to the index 1, right? Because I know that from these 2 numbers, which basically are the 2 numbers I can start from to do my second jump, I will be able to reach one of these 4 values. And I know that once I reach this this roof, I will have to take another jump. So I will basically be at I will have another one here, right? Another jump. Okay, so now that I did my other jump, well, I am free to jump into one of these possibilities, and these possibilities will be roofed, or it's gonna have a roof at this one here. So I cannot jump from a value that is not in that is further to the right than these values. So I will do the same thing. I will go for every single values, and I will go see how far I can go if I start from there. So if I start from the first one, I'm gonna go directly in the middle of my current range of possible step. Um, if I start from the four though, I can actually go one, two, three, and four. I can go out of bound. So this is pretty good for us. It means that we can actually go to the last index with this four. And if we go to the one, well, we can only go one further down. So the maximum span we can go from any of these values is going to be basically an index that is out of bound. Okay. And notice that after this, once we reach this roof here, we are gonna have to take a jump for up to whatever the value is in this in the new span of possible steps. So now our new span of possible solution is here. So we are gonna have to take a jump to this to any of these values. So I'll add another jump here, and also my ceiling now will be any value basically till an index that is out of bound. So notice that from there I can actually reach the last index. So from this four I can jump directly to the last index. So notice that this is giving us a grand total of three, right? So with three jumps, I can actually go to the last index. So I'm gonna start at two, I will go at three. At three, I will go at four. And at four, I will go at one. So this is the shortest way we can go to the last index. We could have decided to pick another path. So we could have gone to two to three, and from one we could have gone to three, could have gone to one. I thought this will have been quite long. Okay, not the most efficient way. So let's now code the solution. First thing I will do is that I will create a variable n, which is going to contain the length of the nums. And then basically what I want to have is I want to have a jumps variable that will basically hold how many jumps I did so far. I want to have basically a span variable, which will tell me up to which index I can go from any of the position I can jump at. And I also want to have my roof. Okay, each of them will be set to 0 initially, which I think makes perfect sense. And now I will go for every single values. So I'll say for I in the range of n minus 1. The reason I don't want to go to the last index is that once we reach the last index, well, in fact, I'm going through every numbers, but the reason I don't want to include the last index is because the goal is actually reach the last index. It is not to go any further to the right of that last index. So if we reach that last index, whatever the value is, well, we completed the problem. So it is not necessary to know what its value is, so or to even deal with it. So that's why I'm saying n minus 1. Okay, and what I want to do is that basically I want to set the span to be the maximum value between the current span. So span, and also how far we can go at this particular position, and how far we can go is basically going to be the index that we're at plus the number of steps that we can take at this particular index, right? And now if we reach the roof, so if the index I is equal to the roof, it means that we are forced to take a jump. So what I will first do is that I will set my new roof to be equal to the span. So this is good. And then I want to take another jump. So jump is going to be incremented by 1. And with that being said, that's everything we have to do. We can simply return jump. And this is going to give us the number of minimum jumps. Oh yeah, I think I initiated jump with a S, right? Which makes more sense because we are... well, I will just put jump like this, no S, all right, no confusion. And let's see this. All right, it works, awesome. So notice that in terms of times and space complexity, we are doing quite good. I'll think I'll let you guess what these are by your own. But if you want to know it for sure, I will basically let you know what they are now. So the time complexity is going to be big of n because we're going to go once through every single value. We're using a sort of breadth first search approach. And for the space complexity, we are not storing anything, right? we're only storing numbers, so this is gonna have a spice complexity of big of 1. Awesome. I hope you enjoyed this video, and I hope to see you in the next one.